There are few vehicles that can offer the thrill and excitement of a modern motorcycle. No car of comparable price can match its performance, and nothing else can move through traffic with such ease. So it's hardly surprising that the motorcycle is so popular, not just as a means of transport, but also as a hobby. Perhaps the most popular machines at present are the race replicas. Built to resemble World Championship Grand Prix machines, they have full racing-type fairings to improve aerodynamic efficiency and thus increase performance. These fairings are made from plastics, and many have unusual visually striking finishes. The majority of bikes now being manufactured have plastic fairings of some sort, including mopeds and off-road trail bikes. Unfortunately, these fairings are very susceptible to damage. Just dropping a bike like this can cause damage to plastic components, which could cost up to 40% of the value of the machine to replace. Quite an expense for the insurance company. And just consider what effect this kind of claim has on insurance premiums. It's all due to the way these machines are repaired at present. Large dealers usually have their own workshops where damaged fairings are removed and replaced with new ones straight from the manufacturer, fully painted and complete with decals. Although that may appear to be satisfactory, there are two principal disadvantages: cost and availability. Take this GSXR, for example. The estimate shows a total repair cost of just over £3,000, and new plastic panels account for a third of this amount. Remember, these are mostly cosmetic items. Then, there's the matter of availability. Manufacturers are forced to hold large stocks of these plastic parts in every available color, going back for several years. And with frequent changes in color schemes, that's a lot of plastic. So obviously, it's in everyone's interest if these fairings can be repaired. Although the technology to repair plastics has been around for some time, it's only in the past few years that it's been adopted to any extent by the car repair industry, and hardly at all by motorcycle repairers. This program will demonstrate repair methods for the most commonly occurring plastics found on motorcycles, showing plastic welding, the use of adhesives, and a repair method for glass-reinforced plastic. Hot air welding can be used to repair most thermoplastics. Components can usually be identified as thermoplastics by the presence of injection molding marks on the back. But it's still essential to identify the type of thermoplastic. With experience, it's usually possible to narrow it down to a couple of alternatives. For example, here the operator has decided that this top fairing is either manufactured from ABS or polypropylene. A test weld is needed to make a final identification. The polypropylene rod will not fuse at all with the base material, whereas the ABS rod appears to bond strongly to the test area. Test welds should always be carried out on scrap material or on a well-concealed part of the panel. After cooling, only the tail pulls off the ABS rod, confirming that the component is manufactured from ABS or a compatible material. This side fairing of a Yamaha bike, although apparently thermoplastic, appeared to be neither ABS nor polypropylene. In cases like this, where identification is difficult, it's usually possible to cut self-made welding rod off a scrap panel, thus guaranteeing a match. However, this material proved impossible to weld, even by this method, but as we'll show later, it is still repairable. Having identified the material, repairs can be carried out. The crack at the side of this Suzuki front fairing is a very common type of damage, which is easily repairable. First, the decal is removed using the hot air gun at a temperature setting of 4.5. Any remaining adhesive is then cleaned off with solvent. Paint must be removed from the area to be repaired. A sharp scraper is used here. Paint and silicone can interfere with the welding process. A small burr is required to open up the crack and remove any loose material. The burr is used past the end of the crack, reducing the depth of penetration until level with the surface. This avoids the need to drill out crack ends. The hot air gun used here has 3 primary modes of operation, each of which require different nozzles. There's one for tacking, there's a pendulum welding nozzle, and 2 speed weld nozzles for use with rods having different profiles. The tacking nozzle is used first. Whenever a different type of nozzle is used, the temperature must be changed accordingly. The gun must be left to adjust to the new temperature for at least 2 minutes. Tacking fuses the existing material together, thus holding the 2 sides in alignment during the main welding operation. The nozzle should be held at an angle of about 20 degrees and run along the crack without applying any pressure. Tacking completed, the speed weld nozzle is fitted to the gun. The welding rod is trimmed to a point to ensure a smooth start to the weld. In this case, the operator has decided to apply a brace across the inner edge to help hold the 2 damaged parts together before he tackles the welding operation to the front of the fairing. When the weld is completed, the gun is pulled away, leaving the rod attached to the workpiece. The excess rod is then trimmed off. With the damage securely held in place, the main welding operation can be started. Before inserting the rod into the crack, the hot air should be allowed to play around the edges until they start to melt. The rod can then be pushed well into the crack, but no pressure should be applied with the gun. The nozzle should remain in contact with the workpiece and the sole should be parallel to the surface. Welding should always be carried out in a well-ventilated area and the gun used at the manufacturer's recommended temperature setting to avoid dangerous fumes. Additional welding rod can be used over any weak areas. A similar operation is carried out to the inside of the fairing. The welded area should be allowed to cool before sanding down with an 80 grit disc. A 180 grit disc is used to finish the sanding operation. Finally, a filler has been used to restore the panel contours prior to painting. At first sight, this side fairing appears to have suffered a multiple fracture. However, with the paint removed, it's obvious that in fact there are just 2 simple cracks, which can be repaired by the same method as was shown previously. Repairs become more complicated when part of the damaged panel is missing. This lug should look much like the one on the other side, although the comparison should preferably be made with a panel from the same side off an identical machine. Having sanded off any paint in the area to be repaired, the small burr is used to remove any unsound material and any paint which the sander couldn't reach. The missing material is to be replaced with compatible material cut from a scrap panel. A pound coin proved to be the ideal template. Here, the operator is using a hot knife to roughly cut out the plastic. It's finally trimmed to size with a pair of cutters and the edges rounded off with the burr. A second section has also been cut to fit the other side. Both pieces are tested for size. Any radiating cracks are prepared with the burr. The edges of the hole and the replacement sections are both abraded at an angle, so that when they're clamped together, they exhibit the standard V shape necessary for welding. Tacking and welding can now be carried out as was shown earlier. Pendulum welding, so called because of the way the hot air gun is played back and forth over the rod and weld area, can be used in tight corners or in other cases like this, where speed welding would be more difficult. Pressure is exerted through the rod, which should be held at an angle of about 85 degrees to the surface. Both the rod and the area to which it's applied must be in the same molten state at the point of fusion. This panel requires very skillful shaping to return it to its original condition. The aim should be to achieve the best possible result before using filler. The filler used on all three of the Suzuki fairings shown has been 3M's flexible parts repair material. This is a material with excellent covering properties. Pinholes may occur, but these will be covered by the primer coats. As we showed earlier, this Yamaha FZR fairing couldn't be welded even to itself. A repair method will now be demonstrated using Terrason's 6700 adhesive system. Having removed the decals, the damaged area is sanded down to remove paint and loose material. Special burrs can be used around lug edges and for cleaning out minor perforations. The main damaged area is shaped on both sides so that the adhesive repair will be supported by the surrounding sound material. An edge-to-edge repair would be very weak. Having completed the preparation, a self-adhesive gauze is applied over the back of the main area to be repaired and pushed firmly into place. Terramix 6700 is a two-component chemical curing adhesive. It's applied over the back of the gauze, thoroughly saturating it and extending over its edges. As the adhesive is pushed into the gauze, it oozes through to the front of the fairing, where it's smoothed out to overlap onto the surrounding plastic. Minor damage requires no gauze. The adhesive is applied like a filler in these areas. The material must be cured for 2 hours at 23 degrees Celsius or for 30 minutes at 60 degrees Celsius using infrared or an oven. The excess adhesive is then sanded off. Any dust is blown off prior to filling with the same 3M flexible parts repair material as was used on the welded repairs. A sanding block is used on the front of the fairing. On the back, where cosmetic appearance isn't so important, a DA is used. But remember that the back of many of these fairings will still be visible after refitting. The fairings on this Honda racing machine, an RC30, are manufactured from GRP. GRP is not often found on bikes, but this is a rare and expensive machine. Indeed, just this one item would cost over £750 to replace new, but it can be repaired for about half of that cost. These are the materials required. glass fibre in 3 different forms: chopped strand and both close and open woven fabric, gel coat filler with hardener and resin with hardener. The damaged fairing is removed from the machine. The first thing to be done is the removal of undamaged items for replacement later, such as this deadening material and the windshield. The windshield rivets must be drilled out, but they're available as a spare part from the manufacturer. Alternatively, a small belt sander can be used for removal. All loose or cracked material must be removed from the area to be repaired. The back of the panel must also be prepared. In this case, the fairing is very flexible, so it's refitted on the machine to provide rigidity during the manufacture of a template. A piece of card has been cut to size based on a shape obtained from the other side. The contour gauge is used to obtain the correct angle. Careful comparison with the undamaged side is necessary to obtain a good end result. This aluminium tape is very useful because it offers good adhesion. It holds its shape and it's easy to remove when the job is completed. A wallpaper roller is a handy tool for shaping the tape. When the template is complete, a final check should be made to ensure its shape matches that of the undamaged side. The 2 woven fabrics are compared with the original to find the nearest match. The chopped strand and the chosen woven fabric glass fibre matting are marked up and cut to size. The gel coat has been weighed out accurately and is now being mixed with the hardener in the ratio recommended by the manufacturer. This is applied to the damaged area, sealing it and providing a sound base for further work. This is left to cure for about an hour until tacky. Meanwhile, the resin has been weighed out and mixed. It's applied to the chopped strand glass fibre matting using a stippling action to remove air bubbles. This diagram shows the theory of application. The whole is built up using the chopped strand matting until level with the surface. A final piece of the chopped strand is applied, extending onto the sound material each side. The sequence is completed with a piece of the woven fabric matting extending beyond the chopped strand already laid. 2 pieces of glass fibre are used here to build up the damaged area, but more may be used if necessary. The woven fabric matting is similarly applied, but only 1 piece should ever be used. Difficulties can sometimes arise in moving glass fibre materials once soaked in resin. To avoid tearing or distortion, chopped strand and fabric matting can be wetted out on the job. Curing should preferably be overnight at 20 degrees Celsius and no heat should be applied for at least 24 hours. The template has now been removed and other damage repaired and sanded down. A resin filler will now be used to shape the panel. This is a 3-part material. The resin and catalyst have already been mixed according to the manufacturer's instructions. Glass spheres are added to bring the material to the required consistency, in this case, that of a light stopper. The filler is applied generously over the repaired area. It's left to cure overnight at normal workshop temperature. This is an excellent filler to use here because it's totally compatible with the other materials used in the repair. Moreover, it's very easy to work. The finished repair demonstrates the excellent results which can be obtained by skilled operators, even when at first sight the fairing may have appeared unrepairable. Repairs completed, there's still a lot of work to be done. The colour must be identified. The necessary primers, ground coats, colour coats and lacquers used, and the decals applied. These matters are all covered in Part 2 of this program.